Biggest mysteries in the universe. Cosmic conundrums and enigmatic mysteries about space that have not yet been revealed. The universe is full of mysteries, from the backyard of our own solar system to the far-off shores of the celestial ocean. That is how it has always been. Ancient astronomers were perplexed by the nature of comets and pondered the chemical composition of stars centuries ago. These old puzzles have been solved, but new puzzles have taken their place as larger telescopes and more sensitive tools look farther into space. Now we wonder about black holes, the fundamental nature of physical laws, and the position of the universe in general. Cosmologists are desperately attempting to comprehend its origin, makeup, and future. They're not there yet, but over the next few decades, solutions might very well be at hand. Who knows what new mysteries we may have learned to ponder by then? How are galaxies created? Through gravity is the straightforward reply. In the young universe, primordial matter was not distributed uniformly. Areas with a slightly higher density attracted more matter over time and grew larger, while empty spaces became drier. Because of this, matter was drawn into lumps that eventually developed into galaxies like our own Milky Way, even though the universe was expanding. Cosmologists use massive computer simulations, such as the enormous Millennium Run carried out by Durham University scientists, to study the formation of galaxies in an expanding universe. Yes, astronomers can simulate the universe in a computer. Following that, the statistics of the distribution of galaxies is compared to the known large-scale structure of the universe. The good news is that one particular model closely matches the observed universe, one in which the majority of matter is made up of dark particles that barely interact with ordinary atoms. This model predicts that filamentary structures should connect galaxies and galaxy clusters, and some observations seem to confirm this idea. But there's a problem. Additionally, the models suggest that large galaxies are surrounded by numerous smaller galaxies, but these are not seen. The formation of the first massive galaxies so soon after the Big Bang also remains a mystery. The picture we have right now might not be complete after all. Is our solar system one of a kind? The fact that this question is even posable is fascinating. Astronomers were unaware of the existence of other solar systems until the middle of the 1990s. It's true that a few sterilized planets have been found orbiting pulsars, compact stellar remnants that emit a lot of lethal X-rays, but nobody was aware of planets that orbit sun-like stars. Has the mystery surrounding our solar system's singularity been clarified? Actually, we now know that it isn't the only one, so in a way, yes. Currently, astronomers are aware of other stars similar to the Sun that are home to one or more planets. Exoplanet hunters have come across a variety of peculiar exoplanets, such as hot Jupiters that appear to have spiraled inward into small, quick orbits, sending other planets into highly elongated paths or ejecting them entirely in the process. In such a system, a small Earth-like world would probably not make it through this game of planetary pool. Therefore, it's possible that there are fewer habitable planets than previously thought. However, future telescopes should be able to do just that, as current ones are unable to detect a solar system similar to our own. They may therefore be quite numerous. Nature never creates a single copy of anything, after all. Although rare, our solar system is most likely not unique. However, until a comparable solar system is discovered, we won't be able to definitively answer this query. What was the Big Bang's origin? This is a very revealing query. You assume a previous event that allegedly had a universe spawning effect in order to determine the Big Bang's cause. However, it's not entirely clear what the word prior means in this context. It's possible that the Big Bang resulted in the creation of space and time as well as matter and energy. It is challenging to discuss a logical cause in that situation. It's not surprising that cosmologists have attempted to prevent the spontaneous creation of the universe from nothing because this is dense philosophical material. Some scientists believed until recently that the universe would eventually recollapse and cause another bang. That notion, however, has since lost favor because we now know that the universe will most likely continue to expand indefinitely. Instead, some physicists propose that the Big Bang was brought about by the collision of two universes that were floating side by side in a higher dimensional bulk space with our empty four-dimensional spacetime. What's even more perplexing is this: if the Big Bang was caused by something, what was the cause of the cause? What manner will the cosmos end? Perhaps it won't. The universe may last forever, despite the fact that people pass away, planets erode, stars explode, and even black holes decompose. It has already passed since the cosmic baby boom, when the rate of stellar birth in the universe was at its highest, and it will take another 100 billion years or so for star formation in many galaxies to almost completely decline. But what about the entire universe? Since the mysterious acceleration of the universe's expansion rate known as dark energy was discovered in 1998, many astronomers think it will never slow down, let alone go back into contraction. Therefore, galaxies will gradually move apart in the far future. They will eventually vanish beyond each other's cosmic horizon, leaving the universe in complete darkness and solitude. The exact order of events is what raises the mystery. In the very long run, perhaps all elementary particles are unstable, and matter will vanish completely. Additionally, the mysterious dark energy that propels the expansion of the universe may grow stronger over time, resulting in a big rip in which space itself is split in two. Was Einstein mistaken? What about the following query: was Isaac Newton incorrect? Although his theory of gravity can propel a spacecraft to the moon, it falters at very high speeds or in strong gravitational fields. In this case, general relativity by Einstein is a preferable substitute. It accurately explains the warping of spacetime around a black hole, the orbital decay of binary pulsars, and the gravitational bending of starlight. So why are we even posing this query? Because it's possible that history will repeat itself. Researchers may find minute effects that point to a more accurate theory of gravity. In fact, it has been suggested that the unexplained deceleration of spacecraft like Pioneer 10 and 11, which slowed down more than would be predicted by the combined gravity of the Sun and planets, is proof of new physics. Over the past years and decades, many sensitive tests of general relativity have been conducted using spacecraft telemetry and astronomical observations. Despite the fact that Einstein's theory has passed each test with flying colors, physicists will continue to challenge it. It might even fail one day and turn out to be incomplete rather than incorrect in the traditional sense. Could there have been a different universe? The four natural forces govern the elementary particles that make up our material universe. The mass ratio between protons and electrons, as well as the strength and behavior of gravity, electromagnetism, and the two nuclear forces, can all be measured by physicists. They can also calculate a number of physical constants, such as the speed of light. However, nobody is aware of the reasons behind all of those values. If the universe could have been different, why is it the way it is now? It is obvious that you shouldn't fiddle with the cosmos's knobs and dials excessively. The universe would become devoid of stars, planets, and life if a small variation in the mass or charge of a particular type of particle, or a slight amplification of one of nature's forces, occurred. It appears as though the universe has been adjusted for the emergence of life, as if nature has been changed to produce complexity. This poses a compelling conundrum. It seems like an eerie coincidence that the outcome would be so unique if the fundamental characteristics of the universe are the accidental result of a random process. After all, the odds of purchasing the winning lottery ticket are extremely slim. However, it's not clear why the only universe that could exist, according to some unproven theory of everything, would have to be a life-supporting one. This mystery might have an answer in the multiverse. Our universe is merely one of a vast collection of numerous potential universes, according to the multiverse theory. If this seems improbable, keep in mind that people have previously resisted ideas along these lines when the uniqueness of the Earth, the Sun, and the Milky Way was questioned. All possible combinations of natural constants, particle characteristics, and force strengths could exist somewhere if there are zillions of universes. We naturally find ourselves in a universe that supports the emergence of life. However, you're not alone if the concept of the multiverse makes you uneasy. Some astronomers assert that the theory is not even science because it cannot be tested. Exists life outside of Earth? There ought to be many other living planets in the universe, regardless of how unlikely the origin of life on Earth may have been. According to the argument, the observable universe contains about 100 billion galaxies, each of which has tens of billions of stars. Even if only one planet out of every trillion of these stars has planets, there are still billions of planets in the universe that could support life. Naturally, the intriguing question of whether or not there is life elsewhere in the universe will only be resolved if and when we discover it. Only a few places in our own solar system, including the planet Mars, Europa, one of Jupiter's Galilean moons, and perhaps the warm interior of Saturn's satellite Enceladus, appear to be suitable for the existence of microorganisms. Astrobiologists would learn right away that life is very prevalent in the universe if they discovered Martian bacteria, whether they are still alive or have long since gone extinct. There is plenty of evidence that Mars was warmer and wetter in the past, but nothing has been discovered as of yet. Astronomers are just beginning to detect the atmospheres of exoplanets as they begin to spread their search nets a little wider. It is almost certain that a planet must have life on its surface if its atmosphere is found to contain significant amounts of oxygen and methane. The evolution of life on Earth from single-celled organisms to anything larger than the period at the end of this sentence took billions of years. So our best chance of finding life may be to look for microbes. However, that limits the search to planetary systems in our immediate area. For this reason, some researchers are attempting to eavesdrop on alien civilizations' radio communications. They might be captured from the other side of the Milky Way if they exist. However, this extraterrestrial intelligence search, SETI, makes the assumption that intelligence and technology are inevitable outcomes of biological evolution. Because evolution lacks any predetermined ends, ask an evolutionary biologist, and they might laugh in your face. And here they are, as Italian physicist Enrico Fermi once quipped. The Fermi paradox states that if there are so many alien civilizations, they should have discovered and visited us a long time ago. No matter how likely it may be right now, the existence of extraterrestrial life is still just a theory. And it's unlikely that will alter anytime soon. It's a funny question because it's impossible to refute the hypothesis. Some people will always think they haven't looked hard enough if nothing has been found. What is the material of the universe? No one knows, is the succinct response. The atoms and molecules that make up the familiar matter that we do understand are merely the proverbial tip of the iceberg. The vast majority of matter is dark and made up of unidentified particles. The vacuum of empty space is filled with a mysterious dark energy that speeds up the expansion of the universe as if that weren't enigmatic enough. Not only are we unaware of the majority of the iceberg, but we also lack comprehension of the murky ocean in which it is submerged. Dark matter can be detected thanks to its gravitational pull. This can be seen by looking at the rotational velocities of galaxies, how they move within large clusters, and how the gravity of the clusters bends the light from nearby background objects. All indications point to the universe having about 30 times as much matter as what can be seen with telescopes. Could dim stars, cold gas clouds, and black holes therefore explain the existence of dark matter? Regrettably, no. The universe would appear very different if all the dark matter were made up of baryons, the protons and neutrons that make up atomic nuclei. The nuclear fusion reactions that took place during the Big Bang would have produced a different set of elements with much less deuterium, heavy hydrogen, than is actually seen because there were so many baryons present. There is no other option if you believed in the Big Bang theory. In reality, the mysterious non-baryonic particles make up the vast majority of the universe's matter. And then there's dark energy. A catchy name, but no one knows what it is. In 1998, astronomers discovered that the current expansion rate of the universe is larger than it was a few billion years ago. Apparently, the expansion of the universe is speeding up, despite the mutual gravitational attraction of galaxies that is expected to slow it down. Dark energy, which can be thought of as being like the repulsive force of empty space, is held responsible for this acceleration. So there you have it, the concordance model of cosmology. Some 70% of the full content of the universe consists of dark energy. The remaining 30% is matter. But only a small part of this matter, 4% of the total content of the universe, is composed of ordinary particles, and at most 1/4 of this baryonic matter, 1% of the grand total, is visible to us as stars and gas clouds. It's a weird tale, that's for sure. Still, most cosmologists are happy with the concordance model. It explains most of the characteristics of the universe, and it appears to be supported by a wide variety of observations, such as detailed temperature maps of the cosmic microwave background radiation, the afterglow of the Big Bang, and 3D maps of the spatial distribution of galaxies. All of the jigsaw pieces appear to fit nicely. The only problem is that nobody knows what the puzzle represents. The makeup of the universe is astronomy's biggest mystery. That's for now. We appreciate you for being here. View more our channel videos.